In this video, I'll be going through this paper here from iGCSE, Cambridge International Exam. Okay, so this is paper 3. So this is for the students taking the core syllabus. Okay, let's take a look at question 1. So in question 1, you're given a list of symbols and formulas is shown here. Okay, this big list here. So answer the following questions using these symbols or formulas. Okay, so basically copying what you have here. So if it's HE, you write HE. If it's K plus, you write K plus as your answer. Okay, each symbol or formula may be used once, more than once, or not at all. So you can use it more than once, or you can and don't use it. Okay, or can use it once. Okay, state which symbol or formula represents a compound produced by the thermal decomposition of calcium carbonate. So if calcium carbonate undergo decomposition, you'll get calcium oxide and carbon dioxide. So the answer is calcium oxide because there is no carbon dioxide here. So for A, the answer is CaO, calcium oxide. So let's write that in here. 2. A positive ion that gives a blue-green color in a flame test. So that is basically Cu2 plus, which is here. Okay, an element used as a fuel. So be careful. You have this word here, which is element. So it must be an element. So although methane, which is CH4, can be used as a fuel, it is a compound because it consists of more than one element chemically combined together. So in other words, you cannot use CH4 as your answer. You need an element that is used as a fuel, which is hydrogen. Okay, so the answer for this is hydrogen. Okay, because you need an element. Next, part 4, the monomer used to produce polyethylene. So polyethylene is produced from the monomer ethene, which is C2H4, which is this one here, C2H4. An ion formed when an atom gains an electron. So if something gains an electron, it becomes negatively charged. So basically you need to look for an ion that is negatively charged, and there's only one option here, which is Cl minus. So the answer for this is Cl minus. So for 5, you just need to look for a negatively charged ion. Okay. Alright, so we are done with part A. Let's move on to part 2. So complete the table below to show the relative charge of a proton, a neutron, and an electron. So the relative charge of a proton is +1. They are already given to us. For neutron, the relative charge is 0. For electron, the relative charge is -1. Part C, choose 2 correct statements about nitrogen and then tick them. So nitrogens are monoatomic. No, they are diatomic because you have 2 N combined together, okay, to form N2. Okay, all nitrogen atoms have 7 protons. So nitrogen, if you go to the periodic table, you'll notice that its relative atomic number is 7. So yes, it is correct. So if its atomic number is 7, so its atomic number is 7, that means it has 7 protons. Next, nitrogen atoms cannot be split into smaller substances by chemical means. Okay, this is correct because an atom is the smaller particle, okay, that cannot be split into simpler substances by any chemical means. Okay, nitrogen have 14 neutrons. If you look at the periodic table, it has a relative molecular mass of 14 and an atomic number of 7. This means it has 7 protons and it has 14 protons plus neutrons. In other words, right, it means that the number of neutrons is 7, not 14. Next, nitrogen is 21% of clean dry air. This is wrong. It is oxygen. Okay, nitrogen is around 79% of your clean dry air. Okay. Moving on to question 2, answer these questions using the information in the table below. So what is this table? What does it show us? It shows us the mass of some ions in 1000 cm³ of sample toothpaste. So it gives us the name of the ion, its formula, and its mass, okay, in grams in 1000 cm³ of the toothpaste. So you're asked to answer these questions using only the information in the table. Okay, so state which negative ion has the lowest mass in 1000 cm³ of toothpaste. So there are 2 keywords here, negative ion and lowest mass in 1000 cm³ of toothpaste. So let's first look at negative ions. So we have Cl minus, F minus, PO4 3 minus, SO4 2 minus. just 4 of them. So now let's compare 0, 0.9, 1.4, 24.4, 9.2. So obviously the smallest is 0.9. So the answer is Cl minus. Next, name the compound that contains NH4 plus and Cl minus. So the keyword here is name, so don't write the formula, okay? So if you want a compound that contains ammonium ions and chloride ions, so basically it is called ammonium chloride, and you need to name it, so spell it out, ammonium chloride. So when you name it, right, it always starts off with the cation, then the anion, so ammonium chloride, okay? Next, calculate the mass of phosphate ions in 250 cm³ of toothpaste. So let's take a look at phosphate. Okay, I know that that is 24.4 grams in 1000 cm³. So in 1000 cm³, you have 24.4 grams of phosphate ions. So now you have 250 cm³ of toothpaste. So how much? What is the mass? So mass of PO43 minus in 250 cm³ of toothpaste is equals to 250 over 1000 times 24.4. So now taking this, so I'll take 25.5 divided by 1000 times 24.4. This gives me a value of 0.622 grams. So the answer is 0.622, or I can just write it as did I get it correct? Hold on. 250 divided by 1000 times 24.4 is 6.1. Sorry. Okay, it's 6.1. So the answer for this is 6.1 grams. So the answer is 6.1 gram. Okay, next, they ask us to describe a test for sulfate ions. So this one is just memory work. To test for sulfate ions, what you need to do is to add nitric acid, or you can write add dilute nitric acid, followed by barium nitrate solution. Okay, so what are the observations if sulfate ions are present? So white precipitate is formed if sulfate ions are present. Right. Next, let's move on to C. Toothpaste also contains cinnamol. The structure of cinnamol is shown here. So describe the formula of cinnamol to show the number of atoms of carbon, hydrogen, and oxygen. So deduce the formula of cinnamol to show the number of atoms of carbon, hydrogen, and oxygen. So basically, they are asking for the molecular formula. And to find the molecular formula, okay, firstly, we know that it contains only C, H, and O. These are the three elements that make up this compound called cinnamol. So next, what we need to do is you need to count how many of each type of elements are there. So let's first count the number of atoms in cinnamol. Let me start from here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 carbon. Okay, let me change the color and let's count the number of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. So 8 hydrogen atoms. Finally, the number of oxygen atoms is only 1. So the molecular formula of this is C9H8O. Okay. Next, moving on, cinnamon can be oxidized to form carboxylic acid. Draw the structure of carboxylic acid functional group to show all the atoms and all of the bonds. Okay, so it can be oxidized to form a carboxylic acid. So which group so they only ask you to draw the structure of the carboxylic acid functional group. So you just draw it out and you get your 1 mark, which is this, COOH. Part 3, ethanoic acid is a carboxylic acid. Ethanoic acid reacts like a typical acid. Complete the word equation for the reaction of ethanoic acid with sodium carbonate. So if you have an acid react with a carbonate, what you'll get, you have a salt, which is sodium ethanoate, plus carbon dioxide, okay, and water. So let's put that in. So you'll have carbon dioxide as well as water, right? Okay, so we are done with this question. Moving on to question 3. So deduce the number of electrons, neutrons, and protons in one atom of the isotope of chlorine as shown. So if you look at this nuclide, okay, tells us that there are 17 protons. There are 17 protons and 37 protons plus neutrons. Okay, and also there is no charge, so it's as an atom, so the number of protons is equal to the number of electrons in an atom. So because there are 17 protons, I know that there will be 17 electrons. Okay, number of neutrons will be equals to 37 minus 17, which will give us 20, and the number of protons will simply be equals to 17. Okay. Next, they asked why chlorine is used in water treatment. Well, the reason is because it kills bacteria, right? So it is to kill bacteria. Okay. Next, part C, aqueous chlorine reacts with aqueous potassium iodide. So this is reaction from periodicity. So this is the group 7 reaction. So the more reactive halogen will displace the less reactive halogen from its aqueous solution, okay, from its ion. Okay, so complete the chemical equation for this reaction. So basically this one is balancing the equation. So you have 2Cl here, so you also need 2Cl here. Once you have 2Cl here, you also have 2K here, so you need to have 2K here. Okay, so you have 2K, you also have 2I, which is balanced. So this is how you balance this equation here. So next, explain in terms of reactivity of the halogens why aqueous iodine does not react with aqueous potassium chloride. So well, the reason is because iodine is less reactive than chlorine and is not able to displace chlorine from potassium chloride. All right. Thank you. Chloride. Okay, so that's the answer. So the key word is iodine is less reactive. Okay. Now moving on to D. So now you have a table of the 4 halogens. So you're given the halogens, their melting point, their boiling point, and their density. So they are asked to complete the table by predicting the boiling point of fluorine, the density of the liquid at their boiling point, and so on. So in order to do this, right, what we need to do is we need to look for trends. So to do so, let's take a look at this. So I know that the difference in the boiling point between bromine and iodine is 184 minus 59, or which is 125 degrees Celsius. The difference between the boiling point of bromine and chlorine is 59 minus negative 35, or 59 plus 35, which is 94. Okay, so I know that probably, okay, here to here the difference is around the change, okay, is 125. The change here is 94. So here to here probably the change will be even smaller than 94. So from between 125 and 94, right, the difference is around 30, right? So very likely this one, the change should be maybe 60. So maybe here I can write it as negative 95. So in fact, in the answer key, any values between negative 40 and negative 210 is correct. Okay, so as long as it follows the trend, you are correct. Okay, next, let's take a look at this. So let's take a look at density. So you have 1.51 for fluorine. This one I don't know. Then 3.12 for bromine, 4.93 for iodine. So you notice that there's an increase in trend in the density. So chlorine must definitely be in between 1.51 and 3.12. Okay, so let's take a look at the difference. 4.93 minus 3.12, it's 1.81. So here to here, the difference, so 3.12 minus 1.51, the difference is around 1.61. So maybe I'll just add 0.8 to this. So maybe I'll just say that it's 2.31. Okay, so for your exams, right, as long as it follows the trend, your answer will be correct. So as long as you have something that is more than 1.51 and less than 3.12, and in fact the answer key says as long as you give a value between 1.6 and 3.0, you'll get the answer. So as long as it follows the trend, you're right. Okay. Next, they asked to predict the physical state of chlorine at negative 150 degrees Celsius. So let's take a look. In order to find the state, you need to look at the melting and boiling point. So we know that at negative 101 degrees Celsius, it is its melting point of chlorine. At negative 35 degrees Celsius, okay, it is the boiling point. Anything above boiling point is a gas. Okay, is a gas. Anything between the boiling and the melting point is a liquid, and anything below the melting point, chlorine will be a solid. Okay, based on these melting point, boiling point figures. So now, where is negative 105? Well, it is below, it is here, right? So minus 105 degrees Celsius is below negative 101. So in other words, it is a solid. So what the answer would be, the negative 105 degrees Celsius is below the melting point of chlorine. Okay, so that is why it is a solid. Okay, moving on to question 4. This question is about acid and bases. Describe the color of methyl orange in acidic and alkaline solution. So this is easy, just memorization. So in acidic solution, it is red, or you can say that it's pink. In alkaline solution, it is yellow. Next, complete the word equation for the reaction between hydrochloric acid with calcium oxide. So hydrochloric acid plus calcium oxide, this is an acid, and calcium oxide is a base. So acid plus base, you get salt and water. So the salt you get is calcium chloride. Okay, and because you have acid and base, you'll get water being formed. So you have calcium chloride and water being formed. Okay, next, calcium oxide is lime. Name one use of lime. So just basically just make any use. So lime has many purposes. It can be used to neutralize acidic soil. Okay, there are also other answers. You can say making cement, making steel, fluid gas, desulfurization, making glass. Okay. Moving on to D, the reaction of hydrochloric acid with calcium oxide is exothermic. So state the meaning of the term exothermic. So this is basically a definition question. So an exothermic reaction is one that gives off heat. Or releases heat, okay? So next, the energy level diagram for the reaction of hydrochloric acid with calcium oxide is shown. Explain why the energy diagram shows that the reaction is exothermic. So why is it exothermic? Because the reactants are at a higher energy level than the products. Okay, so therefore you release energy when the reaction takes place. So the answer is the reactants are at a higher energy level than the products. All right. Question 5. Okay, the question is about group 4 elements and their compounds and so on. Name the change of state represented by A and B. So you have a solid become liquid, is called melting. So A is liquid becomes solid. So basically it is called freezing. Okay. Next, you have liquid becomes gas. So liquid becomes gas, it is called vaporization or boiling. Okay. So this answer here will be boiling. Okay, next, use the kinetic particle model to describe the difference between liquid lead and lead gas in terms of the separation of the particles. So we know that in liquids, okay, the particles are closer together compared to gases, right? So the liquid particles in liquid lead are closer together, while the particles goes in lead gas are very far apart. Okay, I don't want to write the liquid particles because they're just particles. Alright, so this is the answer. Next, they ask about the motion of the particles. So in other words, right, in the lead gas, the particles are moving very fast, right? Okay, they are moving freely. But in the liquid lead, the particles are sliding over each other, so there's more restricted motion. So in liquid lead, the particles are more restricted in their movement and slide over each other. In lead gas, the particles can move freely. Okay. Okay, so that's the answer. Okay, moving on to C, lead is extracted from lead to oxide by heating with carbon. Okay, so describe how this equation shows that lead oxide is oxidized. So let's take a look at lead. Describe this how this equation showed that lead 2 oxide is reduced. So let's take a look at lead 2 oxide and its product. So lead 2 oxide forms lead. So initially it has oxygen, now it doesn't. That means it loses oxygen. So in other words, right, PbO loses oxygen to form lead. So that is why it is being reduced. Okay, next, let's move on to this. Lead is a pollutant of the air. State one source of lead in the air. So basically, it is from the burning of leaded petrol. Okay, so the source is basically your leaded petrol. And sometimes in paints, there are also lead. Okay, state one adverse effect of lead on the health. Well, it is poisonous. It harms the brain. It harms your nerves. It is toxic. So you can write any of this. Harms the brain. Okay, next, E, diamond is a form of carbon. The structure of diamond is shown. Choose the word which best describes the structure of diamond. So draw a circle, okay, around your chosen answer. So it is definitely giant. It is non-ionic, not metallic, not simple. So the answer is basically giant. So it's a giant molecular structure. So the best word to describe it is giant. Name the type of bonding present. It is basically covalent bonding. Okay, so it is covalent. Next, give one use of diamond. It can be used as cutting tools because it is very hard. Okay, it's also used as jewelry because it looks beautiful. So next, deduce the structure of carbon. Use the periodic table to help you. So if we were to go to the periodic table, which is here, so carbon, so if you are interested in the electronic structure, you'll always be looking at the atomic number, which is 6. Okay, so now we know that its atomic number is 6. Let's go back to the question. Okay, so we know that the atomic number is 6, right? 6. So 6, that means it's 2. The first shell can only have 2. The next shell can have a maximum of 8, but you only have 4 more left. So the electronic configuration is 2, 4. Okay. Alright, so let's take a look at this. So we know that we have C, D, E, and F, and we need to answer the questions here. So C, it has a CC double bond, so it's an alkene. Okay, so we know that this is an alkene. This one is an alcohol, D is an alcohol because of the OH group. In E, you only have C and H, and they are all single bonds, so it's an alkane. And F, it contains 2 bromines, so it is a halogenal alkane. Okay, so now state which compound C, D, E, or F will decolorize aqueous bromine. In order to decolorize aqueous bromine, it must be an alkene, so the answer is C. Next is an alcohol, so it is D. Okay, Is saturated, that means is unsaturated, that means it has double bonds or triple bonds, so only C has double bonds. Is in the same homologous series as ethane. So ethane is an alkane. So which one is in the same homologous series? It must be E because it is also an alkane. Moving on to D, petroleum is a mixture of hydrocarbons which can be separated into fractions with different boiling points. Name the method used to separate these fractions. Well, the method used is fractional distillation, because you use fractional distillation to separate a mixture based on their boiling point. Okay, part C is basically memory work. They are asking you to show the name, complete a table to show the name and uses of some of the fractions. Okay, so if you have a refinery gas, it is basically used as a fuel for heating and cooking. Gasoline is basically the fuel used for cars. So you have waxes and polishers. Okay, so it is basically your lubricating fraction. Okay, so basically it's just memory work. Next, some hydrocarbons are formed by the process of cracking. State the meaning of the term cracking. So cracking is basically a process whereby large hydrocarbons are broken down into smaller and more useful hydrocarbons. Okay, so cracking is a process of converting the larger hydrocarbons to smaller and more useful hydrocarbons, or just smaller or shorter hydrocarbons. Okay, describe the conditions needed for cracking. So basically you need heat or high temperature and catalyst. Because they gave us 2 marks, you need to write 2 points here. All right. Okay. Okay, next, question 7. So question 7 is a question about zinc and the compounds of zinc. So zinc is a metal. Give 3 physical properties of metals. So basically metals are good conductor of electricity, good conductors of heat, malleable, ductile, shiny, lustrous, and so on. So you say that it's a good conductor of heat. Once you see there's a good conductor of heat, don't say that it's a good conductor of electricity. Okay, just write one of them. Then it is also malleable. Okay, it is ductile. Okay, it is shiny or lustrous. Okay, and so on. Next, zinc reacts with phosphorus to form Zn3p2. So complete the equation. So basically completing the equation. So you have 3 zinc atoms here. So you need 3 here. 2p here, so you need 2 here, right? Next, part C, molten zinc chloride is electrolyzed. The incomplete apparatus is shown, so you need to complete the diagram by completing the circuit to show the wires and the power pad and labeling the anodes. Okay, so here is positive, here is negative, so you need to connect this portion to the positive terminal of the battery, and the negative electrode is connected to the negative terminal of the battery. Okay, so now I am done with drawing the wires leading to the batteries. Next, I need to label where the anode is. So the anode is basically the positive electrode, right? So this is the anode. Okay, done. Next, I'm going to part 2. Name the products formed at each electrode. So you have the positive electrode, which is the anode. So I have ZnCl. So it contains both Zn2 plus and Cl minus. So Zn2 plus will go to the negative electrode, which is called the cathode. And Cl minus will be attracted to the positive electrode. Okay, because opposite charges attract, which is called the anode. Okay, so now Zn2 plus will go to the negative electrode, and it will form, will go to the negative electrode to form zinc. Okay, and electrons are also given out. Okay, then Cl minus will form Cl2 plus 2E minus at the anode. So the positive electrode will have chlorine being formed, whereas the negative electrode will have zinc that is being formed. Okay, so now let's take a look at this. So zinc chloride reacts with water as shown. The solution form is acidic. State the meaning of the symbol this. So this is basically a reversible reaction. Okay, so this means that it's a reversible reaction. That's why you write a double arrow. Choose the pH value which is acidic. So lower than 7 is acidic. So pH 3. Okay, a compound of zinc has the formula ZnC4H10. Complete the table to calculate the relative mass of ZnC4H10. So there are 4 carbons and 10 hydrogens and 1 zinc. So they have already given us the relative atomic mass. So to find the mass of 4 carbon, I'll take 4 times 12, which is 48. To find the relative mass of 10 hydrogens, I'll take 10 times 1, which will give me 10. So the relative molecular mass of ZnC4H10 is basically adding 65 plus 48 plus 10. Okay, which will give me a value of 123. Okay, next let's move on to question 8. Okay, so in question 8, okay, is a question on the rate of reaction. So a student investigates the reaction of large pieces of copper 2 carbonate with dilute hydrochloric acid. The hydrochloric acid is in excess. In other words, copper 2 carbonate is the limiting reagent. If something is the limiting reagent, that means it is the one that will affect the amount of products formed. Only changing the amount of copper 2 carbonate will change the amount of products formed. Okay, changing hydrochloric acid will not affect the amount formed, okay, because hydrochloric acid is excess. The rate of reaction is found by measuring the mass of the reaction mixture as the time increases. So the reaction mixtures, the mass decreases, okay, because carbon dioxide is liberated. Okay, so if you lose carbon dioxide because it is a gas, okay, the mass will drop. Okay, so they show this on a graph. So deduce the mass of the reaction at 30 seconds. So to do so, you find out where is 30. So let me make this larger. So this is 20, this is 40, so 30 is here. Okay, so here's 30. So moving up, I know that it is here. Okay, so let me see. So here, it should be somewhere here. Okay, so this is 180.40. So this one is 180.50. So each small square represents 0.2. So here it will be 180.42. So the mass is 180.42. Okay, so basically you just need to read off the graph. Okay, now next, whoops. Okay, next, the experiment is repeated using smaller pieces of copper 2 carbonate. So that means smaller pieces, you have larger surface area. Okay, all other conditions remain the same. So you do not change the amount that you use, right? You only change the surface area of solid. So draw a line on the grid to show how the mass of the reaction mixture changes as the time increases. So basically, you just need to draw something that is faster, okay, because smaller size of the solid, that means larger surface area, so the greater the frequency of collisions between reacting particles, so the rate increases, so the reaction takes place faster, it ends faster. But because we do not change the amount that is used, okay, finally you will still end up at this point here, because the same amount of carbon dioxide will be evolved. Okay, so basically just make it a bit faster. So oops, something like this. It's very hard for me to draw on a tablet, so hold on, let me try to do it better now. Okay, something like this, but it should be smooth, all right? Okay. Okay, moving on. Describe the effect of each of the following has on the rate of reaction of copper to carbonate with dilute hydrochloric acid. All other conditions stay the same. The reaction is carried out in the presence of a catalyst. So now if you have a catalyst, that means the rate will increase, right? Okay, so the rate will increase, but so you can write that the initial gradient is steeper because the rate has increased. Initial gradient is steeper, then the final amount of reaction mass, the final reaction mass remains the same. Next, the reaction is carried out using a lower concentration of hydrochloric acid. So when you use a lower concentration, it means that the initial gradient is now gentler. Initial gradient is more gentle. Because lower concentration, the rate of reaction decreases. But because, and next, what you need to note is that hydrochloric acid is in excess. So if you use something with a lower concentration while having the same volume, although you use less number of moles, the amount of CO2 produced will still be the same. Then the final reaction mass remains the same. Part D, when 0.2 grams of copper to carbonate is used, 38 cm3 of carbon dioxide is produced. Calculate the volume of carbon dioxide produced when 0.5 grams of copper to carbonate is used. So basically it's proportional, right? If you use 0.2 grams of copper to carbonate and you get 38 cm3, if you use 0.5 grams of copper to carbonate, you expect more, and it should be proportional. So volume of CO2 is basically going to be 0.50 over 0.2 times 38, which will give us a value of 95 cm3. Hold on now. I want to revisit this question here because I read it again. So they say that they only ask the effect on the rate, so I don't need to write so much detail. So because the question only asks the effect of the following on the rate of reaction, so when the reaction is carried out in the presence of a catalyst, then the reaction rate increases, right? So rate of reaction increases. If the reaction is carried out using lower concentration of hydrochloric acid, then the rate of reaction decreases. You just need to write this way because it's only 1 mark each and they only ask for the effect on the rate of reaction. So just answer the question to the point. Alright. Any others? So that's it for this paper here.